Hello and welcome to this week's blog. As you can see, we're in video form. A few weeks ago I did a talk at the Cambridge Game Dev meetup. It was about creating dynamic characters. More specifically, it was about secondary animation elements to characters. I thought I'd do the talk again for you on the interwebs. So first of all, there was a brief introduction about who I am. I'm Alex. If you don't know, I'm one of the co-founders at Polygon Treehouse. And I used to work as an art director at Sony Cambridge and Gorilla Cambridge. I've got a background in character art and animation. It's actually what I started working in when I graduated from university. That was back in 2002 when PS2 was the current console of choice. And I started making characters, rigging characters, texturing characters. Those times tended to dip your toes in all the different disciplines, which now become more and more specialised. And actually that experience early on in my career stood me in very good stead for becoming an indie developer, and I found I've actually gone back to doing all those things again. And if you don't know, Polygon Treehouse's debut title, which we're working on at the moment, is called Röki, and here's a brief glimpse of it now. As I said, today's talk is going to be the focus on character design and animation, and a pretty specific part, secondary motion elements. What are they and why do I think that they're good? So here you can see Tuve, the main character from our game, and when I'm talking about secondary motion elements, I'm talking about the elements of a character that are outside the core mechanical parts of the body. So they might be the hips, the arms, the legs, all the core anatomical parts that are directly involved in the locomotion of the character. And the secondary parts are the parts that flop around, that follow this core body motion. So for example, with Tuve, we have her bobble hat, the hair strands, a ponytail, and her backpack. So these are the kind of the secondary parts that aren't part of the core body motion, but that follow and react to it. So why are they good? So a large part of creating convincing animation is about getting the placement and shift of weight. And these secondary parts actually help to reinforce that transfer and placement of weight as they follow the main core body parts motion. And as well as reinforcing that sense of weight and weight transfer, they also add a touch of realism to your character, because not everything is moving as part of the same layer. So they make your characters feel more tangible and real and have more depth, and it stops your character feeling like just a collection of rigid lumps. Adds a second layer and range of movement on top that really helps sell the believability of your character, even if it's a stylized character. So in this next slide, you can see an animation breakdown of Tuve's walk cycle. If you just look at the second two examples, you'll see that the final example says Unity underneath. That has all the secondary motion elements applied, and the one before doesn't have any of them. It's the stage before, apart from the backpack. It does have the backpack animating. And hopefully you can see, comparing those two examples, the layer of sophistication and believability that having these secondary animation elements brings. Now, these secondary animation elements can be animated in a number of different ways. They can be hand animated, authored with the rest of the body's motion, or they can also be physics driven. And here you can see Tuve in one of the opening scenes from our game, and you can see her running around, and her physics ponytail is trailing behind her. It's driven by physics, as is her bobble hat and a number of different secondary animation elements. And the good thing about using physics, and we're using Unity physics to drive these secondary animation objects, is that the physics elements can react to the character's movement in world space as they run around. And this is something that if you were to create the motion by hand animating it, you'd have to have a very sophisticated setup to allow you to get a similar reactive nature to those elements. So if Tuve turns in game, the ponytail will whip out behind her, and it's really, it adds a lot and it's really convincing. It also can reduce the amount of hand animation you actually have to do. You don't actually have to go and animate these elements by hand. The physics simulation will take care of it for you. But one of the really important things, and one of the things I really like about using physics animation elements in this way, is that when you're transitioning from one animation to another, sometimes there can be a bit of a join. You can smooth these out a lot when you're creating animations, but the physics-driven elements, they're not blending between one animation and the next. They're just reacting over the top. They have no knowledge of how your animations are transitioning between each other. And so one of the nice things they really do is they add a really nice continuity as you're transitioning between animes, and they really smooth out that transition and mask it, which I really like. And here you can see an early test with Lars, where all his physics poncho, which is using Unity cloth, and his pom-poms. And even with this simple test animation, you can see it adds a great deal of believability to what is quite a stylized character. Pretty cool. But physics is not always the best. We found that for some elements with limited range of movement, for example, Tuve's backpack, we got better results animating it by hand. I think because we could get it just as we wanted it, and the range of movement was quite small, it was better doing it this way. It's also less prone to messing up. Sometimes physics simulations, as I'm sure we've all seen on the internet, can go hilariously wrong at messing up, and you know that if something's hand animated, it's going to be really, really solid and probably need a little less care. But it's really important, if you want to take advantage of having these secondary animation elements, they've got to be there in your character at the first place. So what opportunity do I have to jiggle stuff on my character? And you can only use them if they're there. And so if you have an existing character, you could look at that character and see what elements that are there that could be liberated, could be utilized to be secondary animation elements. But the better way of doing it is to consider it as part of the concept. And fortunately, it's something that we did at the start of our project. We knew that it was something that, well, as an animator, something that I wanted to leverage heavily, because I knew how powerful it was going to be and what it would bring to our characters. And so consider it at the design stage, it's the best thing to do. So here you can see some of Tuve's secondary animation elements, her hair strands, her bobble, backpack, ponytail, so on. And Lars, his poncho and his pom-poms, and here you can see Heinrich, who is their father, and he has some great secondary animation elements, including his resting muscle. And outside of this, there's another aspect of creating dynamic characters is squash and stretch. It's this idea of getting away from rigid 3D shells in your 3D characters. And squash and stretch, I'm sure we all know, is one of the kind of foundation principles of hand-drawn animation. But sometimes it's difficult to incorporate into 3D characters. And early on in my career, we couldn't, on PS2 days, we couldn't scale any joints in animation, which meant that there was no squishing happening. Everything, all the kind of squish you get would be in the posing of the character, which you can still achieve a great deal with, but we've been able to utilize the scaling joints in our animation setup, and it adds a great deal. So you can see Heinrich, and he's there trucking along, and this is quite subtle, but we'll go in and take a closer look. So we actually have squish joints in all of our characters' feet. And we talked earlier about the importance of weight and transfer of weight in our character animation and how important that is to get a believable motion. And one of the things we do to further emphasize that is that when we place Heinrich's foot and it takes the weight, the foot actually spreads out to take the weight. And then when the foot comes off the ground, the foot will slump back and resume its unsquished state. And you may think that this is pretty subtle, and it is, but it's the layering of all these quite subtle elements that gradually build up a sophisticated and believable and dynamic character. I think these things are really powerful. We actually do something similar with Tuve, and when some of our characters blink, we actually squish the whole head, and for parts where she's shocked or scared, having a slightly squishy head, obviously, not anatomically correct at all. People's heads don't really squish that much, but it really helps to sell some of that motion and believability, especially when the characters can be quite small on screen. It's these things that get away from the character being just a rigid, unbelievable collection of lumps. So, congratulations, you made it through. In summary, second narration is pretty cool. Having secondary animation elements in your characters helps to add quite a lot. There's different ways that you can implement them. They can be hand animated, or you could use physics elements in Unity or whatever engine you're using. But it's important to use them at concept, so you have those elements there to leverage in your work. And squash and stretch, that can be quite a powerful thing, and another ingredient to layer on to create really dynamic and believable characters. And that is it. So thanks for listening. Hope you found that interesting, and we'll catch you next week for another Polygon Treehouse blog.